So definite integral advanced level problem. First one. For a belongs to R, modulus of a greater than 1, let limit n tends to infinity 1 plus cube root of 2 plus cube root of 3 and so on cube root of n upon n to the power of 7 by 3 into 1 upon a n plus 1 whole square plus 1 upon a n plus 2 whole square and so on 1 upon a n plus n whole square equal to 54. Then find the possible value of a. Second problem. Yn equal to 1 by n plus 1, n plus 2, n plus 3 and so on n plus n whole power 1 by n where n belongs to n. If limit n tends to infinity yn equal to L, then find greatest integer function of L, that is step of L equal to. So in the first problem, we need to express this numerator and denominator in the sigma notation and write as a function of r by n and then convert into the definite integral. Then a value equal to 8r minus 9. So for the second problem, because it consists of the product, so first n you can take inside, then it will be n to the power of n and split n to the power of n to each factor. So 1 plus 1 by n, 1 plus 2 by n, 1 plus 3 by n, and so on 1 plus n by n whole power 1 by n. Now this you can convert in terms of log as e to the power of 1 by n log of the product, and log of the product you can write as sum of the log. Now this as n tends to infinity, this becomes e to the power of integral of 0 to 1 log of 1 plus x dx, which is the L. Now if you integrate using by parts, then you will get 4 upon e, which is greater than 1 but less than 2. So step of L equal to 1. Next, third problem. F R to R be a differentiable function. F of 0 is 0, f of 5 by 2 equal to 3, and f dash of 0 equal to 1. If g of x equal to integral of x to pi by 2 f dash of t cosecant t minus cot t cosecant t f of t dt, where x belongs to 0 to pi by 2, then as x tends to 0, what is g of x value? Fourth problem. If I equal to sigma k equal to 1 to 98, integral of k to k plus 1 upon x into x plus 1 dx, then first option I greater than log 99, second option I less than log 99, third option I less than 49 by 50, fourth option I greater than 49 by 50. There's a fourth problem, is a multi-answer problem. So in the third problem, g of x equal to integral of x to pi by 2 f dash of t cosecant t. So split into two parts and apply the by parts for the first one. Then this term gets cancelled. Then g of x equal to 3 minus f of x upon sin x. Now f of 0 is 0, sin 0 is 0, that means 0 by 0 form. Apply L'Hospital rule. So f dash of x upon cos x. As x tends to 0, f dash of 0 is 1 and cos 0 is 1. 3 minus 1 equal to 2. So the value will be 2. So here I equal to sigma k equal to 1 to 98, integral of k to k plus 1 upon x into x plus 1 dx. That means x belongs to k to k plus 1. So when x belongs to k to k plus 1, I can take x greater than k and x is less than k plus 1. So when I consider x greater than k, x plus 1 greater than k plus 1, 1 upon x plus 1 is less than 1 upon k plus 1. So multiply with k plus 1 and multiply with 1 by x. So k plus 1 upon x into x plus 1, because the integrand is k plus 1 upon x into x plus 1, which is less than 1 by x. That means I will be less than sigma k equal to 1 to 98. So integral of 1 by x is log. So log of k plus 1 upon k. Now sigma k equal to 1 to 98 log of k plus 1 upon k becomes log 99. That is, I will be less than log 99 base e. In the same manner, previously we have taken x greater than k. It is also x is less than k plus 1. When x is less than k plus 1, 1 upon x greater than 1 upon k plus 1. Now multiply with k plus 1 and divide with x. Divide with x plus 1. So k plus 1 upon x into x plus 1 will be greater than 1 upon x plus 1. Now let us observe the value of x plus 1. When k is less than or equal to 98, because k equal to 1 to 98. So x is less than k plus 1. So x is less than 99. So x plus 1 is less than 100. So 1 upon x plus 1 is greater than 1 upon 100. That means k plus 1 upon x into x plus 1 is greater than 1 upon 100. That means integral I becomes greater than sigma k equal 1 to 98, 1 upon 100, because now this is a constant. So which is same as 99 by 100, 49 by 50. That is I is greater than 49 by 50. So the options are B and D. Next, fifth problem. F dash of x equal to 190 to x cube upon 2 plus sine to the power of 4 pi x for all x belongs to R, and f of 1 by 2 equal to 0. If small m less than or equal to integral of 1 by 2 to 1 f of x dx less than or equal to capital M, then the possible values of small m and capital M. These are the options. Sixth problem. F of x equal to limit n tends to infinity n to the power of n into x plus n by 2 on x plus n by n whole divided by n factor into x square plus n square by 4 and so on x square plus n square by n square whole to the power of x by n where x greater than 0. Then the options are first option f of 1 by 2 greater than or equal to f of 1. Second option f of 1 by 3 less than or equal to f of 2 by 3. Third option f dash of 2 less than or equal to 0. Fourth option f dash of 3 upon f of 3 greater than f dash of 2 upon f of 2. Seventh, integral of 0 to 2 square root of 1 plus x cube plus cube root of x square plus 2x dx equal to. Options are first option A is 4, B is 5, C is 6, D is 7. Now, so here f dash of x is given as 190 to x cube upon 2 plus sine power 4 pi x. Sine power 4 pi x is always positive and which lie between 0 to 1. That means this will be maximum at x equal to 1 and minimum at x equal to 1 by 2 because x belongs to 1 by 2 to 1. So when x belongs to 1 by 2 to 1, so f dash of x will be maximum at 1 and minimum at 1 by 2. That means substitute x equal to 1 by 2 and 1. Then f dash of x lie between 8 to 96. Now integrate on both sides 1 by 2 to x. So integral of 1 by 2 to x 8 dx less than or equal to integral of 1 by 2 to x f dash of x dx less than or equal to integral of 1 by 2 to x 96 dx. Now when you simplify, you'll get 8x minus 4 less than or equal to f of x less than or equal to 96x minus 48 because f of 1 by 2 value given as 0. Now again integrate 1 by 2 to 1. Then you'll get 1 less than or equal to integral of 1 by 2 to 1 f of x dx less than or equal to 12. That means small m is 1 and capital M is 12. So as per the options, it is the fourth option. In the sixth problem, f of x equal to limit n tends to infinity n to the power of n x plus n by 2 and so on x plus n by n upon n factor into x square plus n square by 4 and so on x square plus n square by n square whole to the power of x by n. So this we can rewrite as taking log on both sides, then log of f of x equal to limit n tends to infinity x by n. Now log of this ratio becomes log of numerator minus log of denominator, and again this log of the product you can write as sum of the log terms, that is sigma r equal to 1 to n log of 1 plus rx by n minus sigma r equal to 1 to n log of 1 plus r square x square upon n square. So here you are taking n common from each factor. Here n square you are taking common from each. Then this will be getting cancelled. Now this limit we can convert into the definite integral. So x is a constant. So x into integral of 0 to 1 log of 1 plus xt dt minus x into integral of 0 to 1 log of 1 plus x square t square. So if I take a substitution xt equal to u, then this will become log of f of x equal to integral of 0 to x log of 1 plus u minus log of 1 plus u square, which you can rewrite as log of 1 plus u upon 1 plus u square du. Now when I take differentiation on both sides, f dash of x upon f of x equal to log of 1 plus x upon 1 plus x square. Now, so in this if I take x equal to 2 and 3, so f dash of 2 upon f of 2 is log 3 by 5, f dash of 3 upon f of 3 is log 2 by 5. Log 2 by 5 is less than log 3 by 5. But in the fourth option, f dash of 3 upon f of 3 is greater than f dash of 2 upon f of 2. So that means the fourth option is wrong. Next, when I consider x belongs to 0 to 1, 1 plus x upon 1 plus x square value will be greater than 1. Then f dash of x upon f of x will be greater than 0. And f of x is positive. So f dash of x greater than 0 implies f is increasing. Once f is increasing, you can conclude the second option correct and the first option will be wrong. Similarly, for x greater than 1, f dash of x will be less than 0, that is f dash of 2 less than 0, then we can conclude the third option. So the correct options are B and C. The seventh problem, integral of 0 to 2 square root of 1 plus x cube plus cube root of x square plus 2x dx. Now, so here calculating the definite integral separately or combinedly, it is very difficult. So let us take one of them as f of x. So if I take y equal to cube root of x square plus 2x as y or f of x, then y cube equal to x plus 1 whole square minus 1. And x plus 1 whole square equal to y cube plus 1. So x plus 1 equal to cube root of y cube plus 1. Now, then x equal to f inverse of y plus 1 equal to square root of y cube plus 1. Now we can write this in terms of the functional form. So integral of 0 to 2. So square root of 1 plus x cube will be same as f inverse of x plus 1 plus this will be f of x dx. Now to integrate this, let us go for a substitution f inverse of x equal to t, then x equal f of t dx equal to f dash of t dt. Now when we have taken f of x equal to cube root of x square plus 2x, when x is 0, f of 0 is 0 and f inverse of 0 is also 0. F of 2 equal to 2 implies f inverse of 2 is also 2. So the limits will be again 0 to 2 t into f dash of t dt plus integral of this will be 2 plus integral of 0 to 2 f of x dx. Now apply by parts for this and simplify. So the value will be 6. The option is